It is generally not acceptable to feed a series-rated panel board from one manufacturer using a breaker from a different manufacturer's switchboard, even if the panel board has a main breaker with an amp interrupting capacity rating that is the same or higher than the breaker feeding it from the switchboard. The reason lies in the specifics of series ratings and how they are established. Series ratings are based on specific combinations of overcurrent protective devices that have been tested together by the manufacturer. These tests demonstrate that the combination of devices can safely interrupt a fault current up to a certain level. When different manufacturers are involved, the necessary testing and coordination studies have typically not been performed. The resulting series rating is invalid. It's important to understand that a series rating relies on the upstream and downstream devices working together in a coordinated manner to limit the fault current and energy let through to the downstream components. This coordination is verified through rigorous testing by the manufacturers. Simply having an amp interrupting capacity rating that meets or exceeds the upstream device's rating does not guarantee that the panel board's main breaker will properly coordinate with the upstream breaker in the event of a fault. The listing and labeling of equipment plays a critical role in electrical safety. Equipment is listed by independent testing laboratories, such as Underwriters Laboratories, to verify that it meets specific safety standards. This listing includes the amp interrupting capacity rating, which is the maximum fault current that the device can safely interrupt. The labeling provides information on the proper installation and application of the equipment, including any restrictions on its use in series-rated systems. When using series-rated systems, it is essential to follow the manufacturer's instructions and any limitations specified on the equipment labels. Mixing and matching components from different manufacturers can void the listing and create a potentially hazardous situation. If a fault occurs that exceeds the interrupting capacity of the downstream device, the equipment could fail, leading to fire, electrical shock, or other serious injuries. In any electrical installation, it's crucial to adhere to the National Electrical Code or local electrical codes and regulations. These codes provide minimum safety standards for electrical work. They also require that equipment be installed and used in accordance with the manufacturer's instructions. Section 110.3 B of the National Electrical Code requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. This means that you cannot deviate from the manufacturer's specifications for series-rated systems. There are cases where you can use components from different manufacturers in an electrical system. However, it is crucial to verify that the components are compatible and that the overall system meets the required safety standards. This may involve performing short-circuit coordination studies to ensure that the overcurrent protective devices are properly coordinated and that the system can safely interrupt fault currents. These studies should be conducted by a qualified electrical engineer. In summary, do not feed a series-rated panel board from one manufacturer using a breaker from a different manufacturer's switchboard, even if the panel board has a main breaker with a higher amp interrupting capacity rating. Series ratings are based on specific combinations of overcurrent protective devices that have been tested together. Always follow the manufacturer's instructions and adhere to the National Electrical Code and local electrical codes and regulations. Consulting with a qualified electrical engineer is always a good practice to ensure safety. When dealing with electrical systems and series ratings, several key concepts and considerations must be taken into account. Understanding these aspects can help ensure the safety and reliability of electrical installations. Firstly, the amp interrupting capacity, or AIC rating, is a crucial parameter for overcurrent protective devices. This rating indicates the maximum fault current that a device can safely interrupt without failing. It is typically expressed in thousands of amps, or kiloamps. When selecting overcurrent protective devices, it is essential to choose devices with an amp interrupting capacity rating that is equal to or greater than the available fault current at the point of installation. Secondly, series ratings allow for the use of overcurrent protective devices with lower amp interrupting capacity ratings than the available fault current under specific conditions. The key is that the upstream and downstream devices must be tested and listed together as a series combination. The upstream device, typically a circuit breaker or fuse, limits the fault current to a level that the downstream device can safely interrupt. Thirdly, the coordination of overcurrent protective devices is essential for ensuring that the system operates correctly in the event of a fault. Coordination means that the overcurrent protective devices are selected and set so that the device closest to the fault will trip first, isolating the fault and minimizing the impact on the rest of the electrical system. Short-circuit coordination studies are used to verify that the overcurrent protective devices are properly coordinated. These studies involve calculating the available fault current at various points in the electrical system and then selecting and setting the overcurrent protective devices to provide the desired level of coordination. Fourthly, the National Electrical Code provides guidelines for the selection, installation, and coordination of overcurrent protective devices. Article 240 of the National Electrical Code covers overcurrent protection and includes requirements for amp interrupting capacity ratings, series ratings, and coordination. Section 110.9 of the National Electrical Code requires that equipment be selected and installed to withstand the available fault current. This means that the overcurrent protective devices and other equipment must have an amp interrupting capacity rating that is equal to or greater than the available fault current. Section 110.10 of the National Electrical Code requires that electrical equipment be protected against overcurrent. This includes requirements for the selection and coordination of overcurrent protective devices to protect against both overload and short-circuit conditions. Fifthly, the equipment listing and labeling provide important information about the equipment's capabilities and limitations. The listing indicates that the equipment has been tested and certified by an independent testing laboratory, such as Underwriters Laboratories. The labeling provides information on the proper installation and application of the equipment, including any restrictions on its use in series-rated systems. Sixthly, when designing and installing electrical systems, it is important to consider the available fault current at various points in the system. The available fault current is the amount of current that would flow in the event of a short circuit. It depends on the source voltage, the impedance of the conductors, and the impedance of any equipment in the circuit. Fault current calculations are used to determine the available fault current at various points in the system. These calculations are based on Ohm's law and other electrical engineering principles. Seventhly, the use of current-limiting devices can help to reduce the available fault current and improve the performance of series-rated systems. Current-limiting devices are designed to quickly limit the fault current to a level that the downstream devices can safely interrupt. These devices can be fuses or circuit breakers with current-limiting characteristics. Eighthly, it is always a good practice to consult with a qualified electrical engineer when designing and installing electrical systems. An electrical engineer can perform the necessary calculations, studies, and inspections to ensure that the system meets the required safety standards. Ninthly, it is important to stay up to date on the latest versions of the National Electrical Code and other relevant standards. The National Electrical Code is updated every 3 years, and it is important to be aware of any changes that may affect the design and installation of electrical systems. Tenthly, proper maintenance and testing of electrical systems are essential for ensuring their continued safe and reliable operation. This includes regularly inspecting and testing overcurrent protective devices to verify that they are functioning properly. The following example illustrates the application of series ratings. Suppose that a panel board has a main circuit breaker with an amp interrupting capacity rating of 10,000 amps. The available fault current at the panel board is 22,000 amps. If the panel board is fed from a circuit breaker in a switchboard that is series rated with the panel board's main breaker, the system may be acceptable. However, this is only acceptable if the series rating of the combination is equal to or greater than the available fault current of 22,000 amps. The series rating must be clearly documented and verified by the manufacturer. However, if the circuit breaker in the switchboard is from a different manufacturer, the series rating would be invalid and the installation would not be acceptable, irrespective of the amp interrupting capacity rating of the panel board's main breaker. In this case, the panelboard's main breaker would need to be replaced with a breaker that has an amp interrupting capacity rating of 22,000 amps or higher. In addition to the previous points, several other factors should be considered when evaluating the acceptability of feeding a series-rated panelboard from a breaker in another manufacturer's switchboard. These include the specific types of overcurrent protective devices being used. Different types of circuit breakers and fuses have different characteristics and may not be compatible in series-rated systems. For example, some circuit breakers have faster tripping times than others, which can affect the coordination of the system. Similarly, some fuses have current limiting capabilities that can improve the performance of series-rated systems. The voltage rating of the overcurrent protective devices must also be considered. The voltage rating of the devices must be equal to or greater than the system voltage. Using devices with a lower voltage rating can lead to equipment failure and potentially hazardous conditions. The ambient temperature in which the overcurrent protective devices are installed can also affect their performance. The amp interrupting capacity rating of a circuit breaker or fuse is typically derated at higher temperatures. This means that the device may not be able to interrupt the full rated fault current if it is installed in a hot environment. The altitude at which the overcurrent protective devices are installed can also affect their performance. The amp interrupting capacity rating of a circuit breaker or fuse is typically derated at higher altitudes. This is because the air is thinner at higher altitudes, which reduces the cooling effect of the air on the device. The condition of the overcurrent protective devices should also be considered. Over time, circuit breakers and fuses can degrade and their amp interrupting capacity rating may decrease. It is important to regularly inspect and test overcurrent protective devices to verify that they are functioning properly. The presence of harmonics in the electrical system can also affect the performance of overcurrent protective devices. Harmonics are distorted waveforms that can cause circuit breakers and fuses to trip prematurely. It is important to analyze the harmonic content of the electrical system and select overcurrent protective devices that are suitable for use in harmonic-rich environments. The grounding system of the electrical system can also affect the performance of overcurrent protective devices. A properly grounded system can help to reduce the severity of fault currents and improve the coordination of overcurrent protective devices. The type of load being served by the panel board should also be considered. Some loads, such as motors, can draw high inrush currents when they are started. This can cause circuit breakers and fuses to trip unnecessarily. It is important to select overcurrent protective devices that are suitable for the type of load being served. The maintenance practices of the electrical system should also be considered. Regular maintenance, such as tightening connections and cleaning equipment, can help to prevent electrical faults and improve the reliability of the system. The training and experience of the personnel who are working on the electrical system should also be considered. Electrical work should only be performed by qualified and experienced personnel who are familiar with the relevant codes and standards. Finally, it is important to document all aspects of the electrical system, including the amp interrupting capacity ratings of the overcurrent protective devices, the series ratings of any series-rated systems, and the results of any coordination studies. This documentation can be helpful for troubleshooting problems and for ensuring that the system is properly maintained. Consider a scenario where a facility is expanding and requires additional power distribution. The existing switchboard, manufactured by Company A, has limited space for new breakers. To feed a new panel board, the electrician considers using an existing 200 amp breaker in the Company A switchboard. The new panel board, manufactured by Company B, has a 225 amp main breaker with a 22,000 amp interrupting capacity rating. The available fault current at the panelboard location is calculated to be 18,000 amps. Although the panelboard's main breaker amp interrupting capacity rating exceeds the available fault current, the electrician cannot simply connect the Company B panelboard to the Company A breaker and assume it's safe. Firstly, a true series rating requires testing and listing of the specific combination of overcurrent devices by the manufacturer. Company A and Company B have not tested their devices together, so a valid series rating doesn't exist. Secondly, without a valid series rating, the electrician must ensure that each overcurrent device has an amp interrupting capacity rating equal to or greater than the available fault current at its location. In this case, the 200 amp breaker in the company switchboard must have an amp interrupting capacity rating of at least 18,000 amps, which it likely does. However, the lack of a series rating means the system's safety relies solely on each device's individual amp interrupting capacity rating. Thirdly, the National Electrical Code requires that listed equipment be installed according to its listing. Using components in a way not intended by the manufacturer violates this requirement. Fourthly, a qualified electrical engineer should perform a short-circuit coordination study to ensure that the overcurrent devices are properly coordinated. This study verifies that the downstream device, the panelboard's main breaker, will trip before the upstream device, the breaker in the switchboard, in the event of a fault, minimizing disruption and damage. Fifthly, if a series rating is desired, the electrician should contact both Company A and Company B to determine if a tested and listed series combination exists for the specific devices being used. If a series rating is not feasible, the electrician must replace either the breaker in the Company A switchboard or the main breaker in the Company B panelboard with a device that has an amp interrupting capacity rating equal to or greater than the available fault current. In conclusion, feeding a series-rated panelboard from a breaker in another manufacturer's switchboard is generally not acceptable unless a valid series rating exists. Always consult the manufacturer's specifications and a qualified electrical engineer to ensure the safety and compliance of the electrical system. The concept of let-through current is also important in understanding series ratings. Let-through current refers to the amount of fault current that an upstream overcurrent protective device allows to pass through to downstream components during a short circuit. Current-limiting devices, such as some fuses and circuit breakers, are designed to quickly limit the let-through current, reducing the stress on downstream components and improving the overall performance of the system. When series ratings are established, the manufacturers test the combination of devices to determine the maximum let-through current under various fault conditions. This information is then used to ensure that the downstream devices can safely withstand the let-through current without failing. Mixing and matching components from different manufacturers can affect the let-through current characteristics of the system. Without proper testing, it is difficult to predict how the different devices will interact and whether the downstream components will be adequately protected. The specific application of the panelboard should also be considered. For example, if the panelboard is serving critical loads such as life safety equipment or emergency systems, it is even more important to ensure that the system is properly designed and installed to provide reliable overcurrent protection. In these cases, it may be necessary to use higher amp interrupting capacity ratings or more sophisticated overcurrent protection schemes to minimize the risk of equipment failure. The available documentation for the electrical system is also important. This includes the one-line diagram, panel schedules, and equipment specifications. These documents should be reviewed to ensure that the overcurrent protection scheme is properly designed and that the equipment is properly installed. The documentation should also be updated whenever changes are made to the electrical system. In addition to the technical considerations, there are also legal and regulatory requirements that must be followed. The National Electrical Code and other relevant standards are legally binding in many jurisdictions. Failure to comply with these requirements can result in fines, penalties, and even criminal charges. It is important to be familiar with the applicable codes and standards and to ensure that all electrical work is performed in accordance with these requirements. In summary, when evaluating the acceptability of feeding a series-rated panelboard from a breaker in another manufacturer's switchboard, it is important to consider all of the relevant technical, legal, and regulatory requirements. This includes the amp interrupting capacity ratings of the overcurrent protective devices, the series ratings of any series-rated systems, the let-through current characteristics of the devices, the specific application of the panelboard, the available documentation for the electrical system, and the applicable codes and standards. By carefully considering all of these factors, it is possible to ensure that the electrical system is properly designed and installed to provide safe and reliable overcurrent protection. Let's delve into the scenario with more technical details. Suppose the company switchboard utilizes a standard thermal-magnetic circuit breaker as the upstream device, and the available fault current at the switchboard bus is 25,000 amps. The electrician measures the impedance of the conductors running from the switchboard to the new company B panel board, finding it to be 0.1 ohms. Using this information, the available fault current at the panel board can be calculated. Firstly, the voltage at the switchboard is assumed to be 480 volts. Secondly, the fault current at the panel board can be estimated using Ohm's law. Fault current equals voltage divided by impedance. Thirdly, the fault current is calculated to be 480 volts divided by 0.1 ohms, which equals 48,000 amps. This calculation assumes a bolted fault condition, where the impedance at the fault location is negligible. However, in reality, the fault impedance will likely be higher, resulting in a lower fault current. Nevertheless, it's crucial to design for the worst-case scenario. Fourthly, given the calculated fault current of 48,000 amps at the panel board, the 22,000 amp interrupting capacity rating of the company B panel board's main breaker is insufficient. The electrician cannot rely on a series rating since the devices are from different manufacturers and have not been tested together. Fifthly, the electrician must either replace the company B panel board's main breaker with a breaker having an amp interrupting capacity rating of at least 48,000 amps or implement other fault current mitigation strategies. Sixthly, a potential mitigation strategy is to install a current limiting fuse upstream of the company B panel board. A current limiting fuse is designed to rapidly interrupt the fault current, limiting its magnitude and duration. If a current limiting fuse with a sufficiently low let-through current is used, the company B panel board's main breaker may be adequately protected. Seventhly, the selection of the current limiting fuse must be carefully considered. The fuse must have a voltage rating equal to or greater than the system voltage and an amp rating appropriate for the load served by the panel board. Eighthly, the fuse's let-through current characteristics must be verified to ensure that the company B panel board's main breaker can safely withstand the let-through current. The fuse manufacturer can provide this information. Ninthly, even with the use of a current limiting fuse, a qualified electrical engineer should perform a short-circuit coordination study to verify that the overcurrent devices are properly coordinated and that the system is safe. The study should consider the let-through current characteristics of the fuse and the amp interrupting capacity rating of the company B panel board's main breaker. Tenthly, the electrician must also ensure that the installation complies with all applicable codes and standards, including the National Electrical Code. The National Electrical Code provides requirements for the selection, installation, and coordination of overcurrent protective devices.